everybody. I know it's the second day back to school after a break, but it's the first time I'm seeing you, so welcome back. Happy New Year. I hope everybody's doing well, and we're going to get right back to work. So I have some review questions as today's warm-up, two of them reaching way back to algebra from last year, and one from a recent concept that we studied. Let's see how we did. Everyone has a new seat. If you would make a note of your new number, and the equity bars are in effect. Here we go. Number 1, what did you get? I got student number 8, 3, 2, and 20. Student number 8, what'd you get? Student number 3, what'd you get? Student number 2, what'd you get? Student number 20, what'd you get? All of you have the same results. X is less than 7. Very good. And number 2, what did you get? We got student 19, 13, 7, and 1. Student number 19, what did you get? Okay, and number 13, what did you get? Okay, I think that was a disagreement. Student number 7, what'd you get? Student number 7 is not there. Student number 1, what'd you get?
X is greater than negative 12.
So we get X is greater than negative 12. Remember, to mark your answers correct or incorrect, write down the correct answer if you got something wrong, and we'll go back and try and figure out where you made a mistake. And now the geometry question. What's the centroid of that triangle? We got student number 4, 15, 2, and 19. Student number 4, what'd you get?
1, 1.
Student number 15, what'd you get?
1, 1.
Student number 2, what'd you get?
1,
Student number 19, what'd you get?
1.
So all of you got the same exact point, 1, 1. Let's start with number 3. Could someone tell us the centroid is a special point, and you find it as the result of drawing what special segments? What special segments must you draw? Only 2 people know. I know 4 people got it right. Sharif?
The median.
Yeah. You have to draw the medians of the triangle, and they all meet at a point called the centroid. A median, you may recall, goes from the midpoint of a segment to the vertex that's opposite it. So for example, we could go from here, which is the midpoint, to here, which is the vertex opposite it. That is a median. We could then draw the midpoint of this segment to that vertex. And believe it or not, we already found the centroid. You don't have to draw all 3 because the centroid will show up when you just have 2 of them right there. Did anyone find the centroid without drawing the picture? Oh, we have a bunch of people. Dayanara, what'd you do?
I did the trick.
What's the trick?
Add all the x's and divide it by 3 and all the y's and divide it by 3.
Very good. You find the average of the x's and the average of the y's, and that will give you the centroid. You didn't have to draw a thing, did you? Very impressive, and looked like about 5 other people did the same thing. Matthew, you did the same thing? Okay, Stephanie?
Yeah.
You did the same thing? Anyone do it with only drawing 1 line? You can actually find the centroid just by drawing that 1 line right there. The centroid divides the medians into a specific relationship. Does anyone remember what the relationship is between this part and this part down here? There's a special relationship that you're supposed to know, so make sure you know it now. If you don't have your cheat sheet out, you might want to take that out. That's going to be critical. Kadir?
Like the longer part, which is the top part, is 2/3 of the whole segment, and
That-
the bottom part is 1.
That's right. So this here, from this point to the vertex, is going to be 2/3 of the total distance, and this is going to be 1/3 of the total distance. So you could actually count the total distance and then just find 2/3 of it, and that's going to be the centroid. And look, it's all whole numbers. 1, 2, 3, 4, 5, 6. It's 6 units. 2/3 of 6 is 4. 1, 2, 3, 4. There's the centroid right there. So centroid, very special point in a triangle. Remember, it's also the balancing point. So very, very important. Any comments, questions on number 3? Okay, let's look at number 2. Give me a thumbs up if you got it correct. Good, a bunch of you. Very good. Stephanie T. There was something special you had to remember for number 2. What was the special idea you had to remember? Yeah, if you multiply or divide by a negative number, and here you end up dividing by -2, you must flip the inequality symbol when you do that step. And then, of course, when you write your answer, you want to try and have the variable on the left, so we end up with x is greater than -12. Very good. Excellent job and excellent explanation. Anyone have any comments or questions so far? Okay, well, I had to move the page a little bit so that you can see the whole warm-up, so now you can write the title of today's lesson, Lesson 5.5. And we're going to be using inequalities in a triangle. Any comments or concerns about the warm-up before we get into today's new material? Okay. Today's objectives are to learn how to apply inequalities with one triangle. Next time, we're going to learn how to apply it with 2 triangles. And you're going to also start hearing the phrase side opposite or opposite side. You've heard it before. It's not really new, nor is it very complicated to understand. So let's go ahead and get started with the theorems. These are all on your cheat sheet. Remember, the cheat sheet is a good news, bad news situation. The good news is I've saved you an incredible amount of writing and time. The bad news is that sometimes writing helps you remember things. So you're going to have to make up for that with a little effort. So, unfortunately, according to this publisher, and that's the material and the resources that I'm using to learn my first year, there is not a nice name for the first 2 theorems that we're going to be using. So we're going to call them Theorem 5.10 and 5.11. Not great, but remember the same thing I've said to you all year, which is it's the idea that's the most important. If you have to do a proof and you can't remember the name of the theorem, explain the idea as your reason. So here's the idea. In Theorem 5.10, if one side of a triangle is longer than another, then the angle opposite the longer side is going to be larger than the angle opposite the shorter. So let me hide this for a second so we don't get too overwhelmed. So here we have a side that's 8 units long, and here's one that's 5 units long. This side is longer than this one, which automatically tells us something about this angle and this angle. Angle C is going to be larger than angle A because the side opposite is longer than this side opposite. So again, the idea is the most important thing to understand, but I will refer to Theorem 5.10. Theorem 5.11 is the converse. If you have an angle in a triangle that's bigger than another angle, then the side opposite that angle will be larger than the side opposite the other one. So here we have a 50 and a 30, which means that BC, segment BC, will be longer than segment AB. I don't know the exact measurements, but I know that one is going to be longer than the other. Does anyone have any questions about that? So it works in both directions. That means that the original and the converse, both true. Anyone have any questions? Okay, and then luckily the third theorem does have a nice name, the triangle inequality theorem. And we're going to be using this to solve a lot of problems. The sum of the lengths of any two sides of a triangle, the sum is going to be greater than the length of the third side. This is a critical idea. Again, you can't remember the name of the theorem, that's fine. Remember the idea. When you add two sides together, that has to be greater than the third side. Any questions so far on how the theorems are written out or any of the ideas? The last part that's good news, bad news about the cheat sheet is you can use the cheat sheet as much as you want, but when you have your test on Friday, you will not be allowed to use your cheat sheet. So you're going to have everything in your head. Any questions? So let's go ahead and start solving some problems. Today is going to start out a little bit easier and work our way to a little bit more complicated. For the first bunch of questions, a sketch will be good enough. A sketch will be good enough. So we're given a triangle and we're given the lengths of the sides of the triangle. That will automatically tell us something about the angles in the triangle. And so we are asked to write the angles in order from smallest to biggest. So theorem 5.10 tells us that the largest side, which we can see by this number, is going to be segment FH. The largest side is going to be opposite the largest angle. And the smallest side is going to be opposite the smallest angle. And so that automatically tells us which angles are which. So segment GH is the smallest side, angle F is going to be the smallest angle. The middle side, the middle length side is FG, and the angle opposite it is angle H. So angle H will come next. And then, of course, we already have 2 out of the 3. You know that angle G is the final. And so we are able to order them so we know something about them. We don't know what the angles are, but we know we can rank them in order of their size. Does anyone have any questions on how to use theorem 5.10 to figure that out? So let's look at the converse. Write the sides in order from shortest to longest. And again, a sketch of this triangle is fine. Don't take out the ruler and draw a perfect picture, but don't make a mess either. So using the converse, using theorem 5.11, we can figure out which side is the smallest, which side is the shortest, and which side is the longest. But we need the angles. So we're given 2 of them. 1 of them is missing. So what do we do about that? We use our brains. Come on. Good. How do you know you can do that? Nicely stated. Absolutely. So what is the third angle of this triangle? Did you already figure it out? Anyone figure it out already? John?
48 degrees.
It is 48 degrees. By doing exactly what Kamoy described, using the triangle sum theorem. So now we can rank the lengths of the sides. So which side is going to be the which side is going to be the shortest? Alexandra? Q. Yeah. Segment QP is going to be the shortest. It is opposite the smallest angle. Which side is going to be the middle side? Which one's going to be in the middle? QR is opposite the middle size angle, so segment QR will come next, and then that leaves PR as our largest size, our largest side. Anyone have any questions on how we work that out? Any concerns? Anything at all? So, checkpoint number 1. Write the sides in order from shortest to longest. We only have one question. Got about a minute. Actually, I'll put up a minute and a half. Compare your answer to your new teammates when you're done. See if you can come to an agreement. Again, when you finish, compare your answers with your new teammates to see if you all agree. All right, let's see how we did. I got student number 6, 5, and 17. Student number 6, give me the shortest side. Shortest side is EF. Student number 5, give me the middle side. Middle side is DF, and last student, you don't need to tell me anything because we already know that the last one is DE. Sorry about that. Student number 17, I'll get you for the next one. So does anyone have any questions on how we use theorems 5.10 and 5.11 to help us just identify some things about the triangles? Okay, so let's step it up a little bit and now start talking about the triangle inequality theorem. You do not have to copy anything here. Please just look. Sometimes it's just more important to concentrate rather than focus on the writing. We already know that a triangle is formed by 3 segments. But that doesn't mean that you could just take any 3 segments and make a triangle out of it. It will not always work. So how could you figure out which ones will work and which ones won't? Well, here are 2 examples. On the left, I have segments of length 7 units, 4 units, and 4 units. That will form a triangle. But look at the right. If I have 7 units, 3 units, and 3 units, it will not form a triangle, no matter what I do. if we try to, bend this line down a little bit and bend this one down, they will never meet at a point. I can't stretch them back. I can't bend them up this way. There's nothing you can do to make it work. So you can't just pick any size lengths. They have to actually work. And so using the triangle inequality theorem, we can determine whether or not three sides will actually form a triangle. So you already have this down, but here it is again. The sum of the lengths of any two sides of a triangle is going to be greater than the third side. So we're going to do some quick mental math. Everyone's going to do it along with me. Let's look at the triangle on the left. Pick any two sides. Let's start with the 7 and the 4. Add them together in your head. Is it greater than the third side? Yes. Let's take the 4 and the 4. Add them together. Is it greater than the third side? Yes, it is. Take the other 7 and the 4. It's going to come out the same. Of course, it's going to work. So no matter which two we take together, it always works. But let's look at on the right. If we take the 7 and the 3, add them together, is that greater than the third side? 7 plus 3 is greater than 3. But now take the 3 and the 3 and add them together. What happens? It's only 6. It's not bigger than the third side, and that is why this will not form a triangle. Okay? Any questions about what we're exploring? So let's go ahead and use this to figure out some triangles. So, in part A, I have the lengths 7, 10, and 19. It doesn't matter what the units are. It could be centimeters, it could be inches, it could be feet. It doesn't really matter. We're talking about the same unit of measurement. Tell whether a triangle can have the sides with these lengths and explain. Remember that an explanation could be words, but it can also be a diagram. It could be math work. It could be a lot of different things. It could be an explanation. So let's explore and see if these three numbers will work. Let's just start by going in order. Let's add 7 plus 10. And for it to work, that has to be greater than the third side. Is it? You can just shout it out. Is it? No. It is not. So unfortunately, we already know that this is not going to work. But let's just, for experience sake, let's just check the other ones. So let's add the 7 to the 19 and see if that's going to be greater than the third side, which is 10. Is that going to work?
Yeah.
You can just shout it out.
Yeah.
Yeah. And now let's try the 10 plus the 19. Is that going to be greater than the third side? Yes, of course. In fact, my super high level students who are sitting in the room right now, some of you will figure out that there's only one statement you actually have to figure. Don't tell me, you just figure it out for yourself. I don't have a lot of experience, so I'm going to check all of them. But there's really only one that you have to do. Don't worry, most of you will figure it out. So we already know that this will not form a triangle. So the answer is no, it will not form a triangle. But what about part B? What about the lengths 2.3, 3.1, and 4.6? Will those form a triangle? Well, let's check them. 2.3 plus 3.1, is that greater than 4.6? Well, I could do mental math and just add the ones place, and I can already see 2 plus 3 is 5, yeah, that's going to work. So maybe it will be a triangle. Let's try the 2.3 plus the 4.6. Is that greater than the third side, which is 3.1? Again, I can do mental math just using the ones place. 2 and 4 is 6. That's clearly greater, so that's going to work. Now the third statement, 3.1 plus 4.6, is that greater than the third side, which is 2.3? And again, you can clearly see that it will work. So based on this evidence, this explanation, we can say, yes, this will form a triangle. Does anyone have any questions about how we arrived at this conclusion? Give me a thumbs up if you figured out which is the one statement you have to do and you can figure it out. A few people figured it out already? Good. So from now on, you can just do that one statement. Don't tell anybody, though. Let people figure it out for themselves. Any comments, questions? Okay, checkpoint number 2. Some of you, it's going to take you a lot less time than others, so I'll compromise and I'll put 2.5 minutes on the clock. If everyone on your team is done, compare your answers. It's a yes or no question, but there needs to be evidence. There needs to be an explanation. Got it? You all got it? You all got the same thing? All right, you've had a chance to check. So let's see how we did. Now let's do this by survey. Part A, give me a thumbs up if you think you can form a triangle with those lengths. Not too many people think so. And the answer is no, you cannot. And here is the evidence. Right here, this third statement doesn't work. What about part B? Give me a thumbs up if you can form a triangle with those lengths. Okay, I got a few people over here who think so, a lot of people over here, some people over here, some people don't. And for part B, yes, you can. And if you check all the statements, They all work. But of course, my really high-level students know that there's only one that you really have to do. Anyone have any comments or questions at all? Before we take it one step further. Any comments or questions? Any concerns? Okay, so now, what if we take it a step further? What if we actually wanted to know the length of the third side if I have two sides given to me? Or what possible sides could be the third side? So, we're given two sides, 8 inches and 13 inches. What I did was I drew out, I actually used the tools here. I actually have a ruler tool right here, but it ended up being a little too big. So I measured out 8 inches and then I measured out 13 inches. I grouped it and then I shrunk it down proportionally. So this is 8 units and this is 13 units. It's not inches anymore, but it's still the same basic idea. So you can tell that this is the 8 and this is the 13. So the question is, what would the length of the third side have to be? So you don't have to write anything yet, just watch. So here's the third side right now. If I have the lines exactly like this, then the third side will go from there to there. Okay? So that's the length of the third side. So that's one possibility. Okay? So let me turn this. So that's one possible length. But what if I took this, and unfortunately my computer doesn't work exactly the way I would like to, but what if I rotated it a little bit and I put it back there? That's still, I didn't change the length. All I did was turn it, right? Now let me draw the third side again. Let's draw the third side this time. And now, is that the same as what I drew the first time? Let's see. Should be able to tell that even though it's a little bit crooked, that's not the same length. In fact, I could keep doing this over and over again. I could rotate this even more. I could rotate this and then draw yet another line. Not perfect, but close. And you can see again, it's even short, it's still shorter. So the question is, how many different lengths are there? And what is the smallest and what's the biggest? And that's the question that we have to answer. Does anyone have any concerns about what I'm proposing here? Okay, so let me get these out of the way, and now let's use math to try and figure this out. If this is the 8, and this is the 13, and we don't know what this is, what would we call it? What would we call it? Could you hear? We'd call it x, or some variable. And so that means that we have the side lengths 8, 13, and x. But we don't know if x is the biggest, we don't know if it's the middle, or if it's the smallest. We don't know what length it is yet. But we already know, based on our experience with 4 different questions, that we can write these inequalities, and we know that for it to work, when we add 2 sides, it has to be greater than the third side. Right? So, if we take the 8 and add the 13, that must be greater than x because of the triangle inequality theorem. That has to be true. So let's solve that and see what happens. What do we get? We're talking about What do we get, Nathaniel? Right, x is less than 21. All right, so we got something. Not sure what we figured out yet. But remember that there were 3 different statements that we could write. We don't know what the order of this is. What if the x was actually the smallest? Excuse me. What if the x was actually the smallest side? Well, then we would have x plus 8, and that would have to be greater than the 13. That's if the x is the smallest. Right? So, solve that. What do we get? Nathaniel seems to be on a roll. What do we get?
Okay.
X is greater than 5. What if the x is in the middle? Well, what's the one statement that we haven't done yet? Yeah, the x plus 13. So if we do x plus 13, I didn't leave myself enough space. Let me just move this over. So if we do x plus 13, that has to be greater than the 8. Anyone notice anything? Students who are really operating at a high level. Anyone notice anything? X plus 13 is greater than 8. Okay, you don't notice anything? Go ahead and solve it. You don't have to write anything. You solve it. Come on, it's mental math, guys. Let's go. What does it come out to? Zimara, what does it come out to? X is greater than -5. Is that possible? So someone tell me why we should have known just by looking at this that it wasn't going to work. Why is it not going to work? John?
13 is greater than 8 already.
Yeah, 13 is greater than 8 already. You can't add anything to 13 to make it greater than 8. It's already greater than 8. You would have to, this just wouldn't make any sense. So this last statement doesn't have any validity in the circumstances. And so what you want to do is figure out, basically you want to take the x and pretend that it's the smallest, so it's over here. And then you want to take the x and pretend that it's the biggest and put it over here. And now we want to put this together as a statement. We want to now make this a range. It says find the range of possible lengths. You learned in algebra how to write a range. You put the x in the middle. Smallest number goes on the left, biggest number goes on the right. And so we end up with this statement. And what we figured out is that if we had a length of 5, it actually would not work. But a little bit bigger than 5 will work. Remember, it doesn't have the or equal to. If it had the or equal to, then it could be exactly 5, but we don't have that. And the biggest size is just under 21. And so we have figured out the range of possible lengths for this third side over here. Anyone have any questions or concerns about that? Questions or concerns? Okay, so let's just explore it again, this time without a picture. We are given the sides of a triangle, 22 and 17 inches. What's the range of possible lengths for the third side? So let's explore the two scenarios because we want the range We need to explore when the third side is the smallest, and we need to explore when the third side is the biggest. The third side being the smallest would be x, and then 17, and then 22. The biggest would be 17, 22, and then x. And let's explore the inequalities that result from those assumptions. So now this would lead to x plus 17 would have to be greater than 22. This one leads to 17 plus 22 has to be greater than x. Solve each of those. It's all mental math. So, we get x is greater than 5, and that's a coincidence that it's the same as the previous one. That was not done on purpose. And then we get 39 is greater than x, or x is less than 39. And so now we've identified the smallest possible length and the largest, and we put it together as a compound inequality. So now we can say a statement like this. The third side has to be just over 5, and it has to be just under 39, or anything in between. Anyone have any comments, questions, or concerns about how we went about this? Or why we don't do that third inequality, or anything at all? Okay, final checkpoint. You do not have to copy anything, but you need to find me a solution. You got 2.5 minutes. If there's time left before the bell rings, then you compare your answers with your teams. a chance to compare with your teammates? All right, let's see how we did. What is the range? I got student number 20, 15, and 19. Student number 20, what'd you get?
X is greater than 28 and X is less than 72.
Okay, student number 15, what'd you get?
X is greater than 28 and less than 72.
You agree there. Student number 19? X is greater than 28 and less than 72. Anyone have any concerns or any issues with this? Anything at all? So today we explored these three theorems. We really kind of looked at theorem 5.10 and 5.11 together because one's converse of the other. And then we used the triangle inequality theorem to be able to prove whether or not three lengths could be a triangle or to find a range of sides when given two sides. Anyone have any questions about anything that we did today? Anything at all? Okay, draw a line across your paper. Your homework is on page 333. You're doing numbers 6 through 12, 16 through 26. Then you're doing numbers 33, 34, 41, and 44. You see that I put in bold number 33, 34, and 41. That's where most of your time is going to be spent. Number 41 is a special type of question. It's 4 different drawings you have to make. So you're going to have to use a ruler and you're going to have to make 4 drawings. There are many possible answers. So the answer sheet has sample answers. You need to use your brain to figure out whether your answers make sense. Each drawing is worth 1 point. So that one question is really 4 points. So there's a total possible of 25 points on this homework assignment. Then I would like you to read the next section. Make sure you read what's coming up next. It's going to give you a huge advantage, a huge insight into what we're going to be doing. Or do the at-home tutor for the next lesson. And then you are going to have your Chapter 5 test on Friday.